Good morning, students. In the earlier video of acid, base, and salt chapter, we had seen the introduction part, the theory of acid and base given by Robert Boyle as well as Arrhenius, and the limitation of Arrhenius acid-base theory. Now, moving on further, we'll be seeing Bronsted-Lowry acid-base theory. According to Bronsted-Lowry's opinion, the substance which donates a proton, that is H plus, to the other substance, it is called acid. The substance which accepts a proton, that is H plus, from another substance is called base. According to this theory, the species responsible for acidity is not hydrogen ion but H3O plus, because the hydrogen ion forms bond with the water molecule and forms hydrated ion, that is H3O plus, which is also known as hydronium ion. In hydronium ion, there is a coordinate covalent bond between hydrogen ion and water, because the bond between them is formed by sharing of electron pair on oxygen atom of molecule. We see in the last part of the equation, the arrow pointing towards hydrogen shows the coordinate covalent bond formed by hydrogen ion with that of water molecule. Taking one examples for Lowry-Bronsted acid-base theory, that is hydrochloric acid, which acts as an acid, reacts with the base water to give you hydronium ion H3O plus Cl minus, which is the negative ion. Ammonia, that is NH3, which acts as a base when reacts with water, which acts as an acid in this equation, gives you NH4 plus OH minus. If you see in the earlier two reactions, you can observe that the water acts as both acid and base. So it is called amphoteric. So it is known as amphoteric. We'll just see that water, when acts as a base and an acid, when react together, it gives you hydronium ion plus hydroxide ion. We'll just recall it to make the content clear in your mind. Bronsted-Lowry acid-base theory. According to this theory and opinion of the scientists, the substances which donate proton to the other substance is called acid, whereas the substances which accept proton from another substance is called a base. Here, in this theory, the species responsible for acidity is not hydrogen ion. It is hydronium ion, which is formed when hydrogen ion combines with that of water molecule. In hydronium ion, there is a coordinate covalent bond between hydrogen ion and hydronium ion, because the bond between them is formed by sharing of electron pair on oxygen atom of water. Here, one example of acid as well as base of Bronsted-Lowry acid-base theory is given. Hydronium, that is hydrochloric acid, when reacts with water gives you hydronium ion plus chloride ion, whereas ammonia, when reacts with water, gives you NH4 plus OH minus, that is hydroxide ion. In the earlier equations, we can see that water acts as both acid and base, so it is known as amphoteric. Now, moving on further, chemical properties of acids and base. First is, when the oxide of a non-metal reacts with water, it gives us acid. This is the general equation which we should remember while writing the equation. Oxide of a non-metal when reacts with water gives us acid. We'll just take two examples of it. Carbon dioxide when reacts with water gives you carbonic acid. That is CO2 plus H2O gives you H2CO3. The second equation is sulfur trioxide when reacts with water gives you sulfuric acid. SO3 when reacts with water, that is H2O, gives you H2SO4. Now, metal oxide when reacts with water, it gives you base. Lithium oxide when reacts with water, gives us lithium hydroxide. Li2O plus H2O gives you 2 LiOH. Same way, when the sodium hydroxide reacts with water, it gives you sodium hydroxide. Now, chemical properties of acid. Reaction of an acid with metal. When an acid reacts with metal, the salt of the metal and dihydrogen gas is produced. You'll recall once again, when an acid reacts with metal, it gives us salt of metal and dihydrogen gas is produced. When hydrochloric acid reacts with calcium, it gives you calcium chloride plus hydrogen gas. 2HCl, when reacts with calcium Ca, gives you CaCl2, that is calcium chloride, plus H2, that is dihydrogen gas. Second example is sulfuric acid when reacts with magnesium. It gives you magnesium sulfate plus dihydrogen gas. That is H2SO4 plus Mg gives you MgSO4 plus H2. Nitric acid being an oxidizing agent, by the reaction with metal, water is produced instead of dihydrogen gas. Nitric acid, when reacts with zinc, gives us zinc nitrate plus nitrogen oxide plus water. 8HNO3 plus 3Zn gives you 3ZnNO3 twice plus 2NO plus 4H2O. Just recall the properties one more time. It is the chemical properties of acids and bases. Oxide of a nonmetal when reacts with water gives you acid. That is CO2 plus H2O gives you H2CO3. Carbon dioxide when reacts with water gives you carbonic acid. Sulfur trioxide when reacts with water gives you sulfuric acid. SO3 plus H2O gives you H2SO4. In that itself, metal oxide when reacts with water gives you base. Lithium oxide when reacts with water gives you lithium hydroxide. Same way, sodium oxide when reacts with water gives you sodium hydroxide. Li2O plus H2O gives you 2 LiOH. Na2O plus H2O gives you 2 NaOH. Moving on to the first chemical property of the acids are reaction of an acid with metal. Whenever an acid reacts with metal, it gives you salt of the metal and dihydrogen gas is produced. So hydrochloric acid when reacts with calcium gives you calcium chloride plus dihydrogen gas. 2HCl plus Ca gives you CaCl2 plus H2. Sulfuric acid when reacts with magnesium gives you magnesium sulfate plus dihydrogen gas, that is H2SO4 plus Mg gives you MgSO4 plus H2. Nitric acid being an oxidizing agent, by the reaction with metal, water is produced instead of dihydrogen. Nitric acid when reacts with zinc gives you zinc nitrate plus nitrogen oxide plus water molecule. 8HNO3 plus 3Zn gives you 3ZnNO3 twice plus 2NO plus 4H2O. Hope you all might have understood this content.